Alright, welcome back. We're going to take a look at the next limit problem. Over here we have the limit as x approaches 3, and first step is to just try our direct substitution. You plug in 3 squared, you get 9 minus 9, so you get a 0 on top, and 3 cubed is 27. 27 minus 27 is 0 over 0, so that's you can't determine that one, so we have to go to the next step, which is try and factor it. Well, the top is pretty easy. It's a square minus a square, so we have x plus 3, and then we have x minus 3. And the bottom, just to review, it's a cube minus a cube. So remember, this can be written as x to the third minus 3 cubed, and hopefully that'll spark your memory that this is like saying a cubed minus b cubed, and there's a formula. It's a minus b, and then the rest of it becomes a squared, and then you do the opposite. So it starts off as subtraction. This one's always going to be the opposite operation. So, and then the second term is a times b, and then the last one is always plus and b squared. And kind of a dorky way to remember that is when it's SOAP. The same operation here, the opposite here, and always plus. So it works for a cube minus a cube and a cube plus a cube. So anyway, hopefully that helped a little bit. Let's go ahead and factor that one out since we talked about it here. So our a is going to be x, so we have just x minus 3. And then square the first one, x squared, right? And 3 times x, so it becomes plus 3x, and then plus 9. And then of course you can cancel out like terms there. And now try directly substituting in your 3, and you get 3 plus 3 on top, so you get 6 on top, and 3 there is 9, plus 9 more is 18, plus another 9 is 27. So your limit is, divide that by 3, you get 2 ninths. So that's a neat little problem there. Okay, let's move on to the last couple here. Actually, there's 3 more. So let's do this ln of x minus 1, x minus e. First thing we're going to try to do is just direct substitute, and you'll see that you get the ln of e, which is 1. So you have 1 minus 1 over e minus e, and that's 0 over 0, which is indeterminate again. So don't really have any tricks for factoring this one, but let's pretend like well, what is the ln of e? We just said the ln of e is equal to 1. So this really can be rewritten as, say, the ln of x minus the ln of e over x minus e. So this, hopefully this will this looks a little bit like a slope formula, right? Where you have the y on top and the x's on the bottom. So certainly they're just asking us to find the derivative of ln of x and then evaluate that at e. So what is the derivative of ln of x? It's just 1 over x. And then they want us to evaluate it at e, and that's determined from that spot there. So the answer to this is just 1 over e. Alright. Looks like we have maybe a similar situation here working, where we have plug in 1, you would get e to the first minus e to the first, 0, and then 1 minus 1 is 0 on the bottom. So this is just, this 1 is actually right there, but it's not necessary to write that. So this is just another slope formula, which should prompt you to think about the derivative. So what is the derivative of e to the x? And then they just want us to plug it in. So that's just e to the x, and then plug in 1. So the answer for this is just e to the first. Okay. The very last one Anytime you see this limit as h approaches 0, you ought to be thinking about, they're asking for the derivative. And but here there's no function value. They're just saying function value of 7 plus h minus f of 7 divided by h is equal to -3. So really what they're saying is the derivative at the number 7 is equal to a -3. So that's about all that we can gather from that. Sometimes I'll try to tie that piece of information in with another part of the problem they want you to solve. Maybe it's find the equation of a tangent line or something, and you needed that point at 7, so you would use that -3 as a slope. Alright, well hopefully this jarred your memory on limits a little bit, and we'll try some derivatives next.